Alright, so I think I'm recording. We are looking at the solutions to our day one of inverse functions, and the directions have asked us to find the inverse, find the equation for the inverse, and also to determine if it is a function. So here in number 10, I can see that I'm given a quadratic function because it's x squared. Um, I know that quadratic functions that we call the graphs parabolas, and they look U-shaped. The difference between problem 10 and the problem in problem 9 they gave us the function already in vertex form. This is just in your standard form, ax squared plus bx plus c. We need to write it in vertex form. So here's another application of using completing the square, not to solve an equation, but to algebraically change the form. I want to change the form of this equation from standard form to vertex form. So this g of x, I'm going to focus my attention on the first two terms for just a moment. Well, I like the fact that this x squared has a leading coefficient of 1. And I love the fact that the coefficient in front of 12 is an even number. Students don't like it when it's odd. Students really don't like it when it's a fraction, because the technique of completing the square, I take half of this number. To take half of 12 is pretty easy. That's 6. To take half of 3/4, you got to recognize that's 3/8. And then to square that, that's 9 over 64. That's not as easy. Well, half of 12 is 6, and then 6 squared is 36. So I'm going to add 36 to this. Now, don't forget that I have this minus 4 out here. And I just changed the problem by adding 36. I'm not allowed to do that. But what if I come over here and just turn right around and subtract 36? Is it clear that the 36 and minus 36, now I haven't changed the problem? Why did I do that? Because I don't have to use an x method. I don't have to use very much thought at all. I know that this factors to x plus 6 squared, because half of 12 is 6, and I added the correct amount so that it would become a perfect square. That's how it got its name, completing the square, is this idea in that step right there. The minus 4 and minus 36 is minus 40. Now, don't forget that I have this x greater than or equal to negative 6. Now, at first you might sit there and think, well, why is this a negative 6 when inside the parentheses that says positive 6? Bizarro world, remember? Let's sketch this graph of g knowing what we know about function transformations. I know the parent function, x squared, opens upward with its vertex setting at the origin. I know the plus 6 is a horizontal shift to the left. So over here at negative 6, this whole graph shifts as a rigid structure. And now the vertex is at negative 6, 0. The minus 40 pushes this down 40 units, so that my vertex is negative 6 comma negative 40. Now, if I didn't have this restriction, if I applied the horizontal line test, it would fail. But they have came in and said, hey, we're going to restrict this domain. We do not want the whole parabola. We only want the parabola that has x coordinates that are equal to negative 6 or larger. It's the values on the right here. These points all have x coordinates that satisfy this inequality of x greater than or equal to 6. So this other portion is not on my graph. I'm not allowed to have any points that have x smaller than negative 6. no points to the left of negative 6. So now when I apply my horizontal line test, hey, it passes. So this inverse that they're wanting me to find, even though the directions kind of state it in that order, find the inverse and then determine if it's a function or not, I'm answering it in backwards, but still the correct answer, that because my original function g is a one-to-one function, I know the inverse is going to be a one-to-one function. All right. Now I need this equation, so I need some room. I'm going to erase some of this work, but I need, when I completed the square there, I need that stuff. So let's erase my scratch work here that was justifying that what I have here is a one-to-one function. That was that purpose. And now let's even shrink this up a little bit, because if we need it, we can always make it bigger. All right. Let's dig into this equation. Let's write it in terms of x and y. Let's not use function notation. Let's write this as y. And I remember my y coordinate. This opened upward, so my range is bigger than or equal to negative 40. Think back of my picture. It was negative 6. Negative 40. Negative 40. And it was the right half of that parabola. It was like that. Okay. So I can look at that and say, hey, all of these points on my graph all have a y coordinate that's bigger than negative 40, so that's my range. I need that because now the idea of an inverse is going to switch the domain and the range. When you switch the domain and the range in your equation, all of your y's have now turned into the variable x, and all of the x's are now y. Not only in my equation, but for the entire domain and range. So since this was an inequality that described the domain, it's now an inequality that describes the range. This was an inequality that described the range, but now it describes the domain. So we need to solve this equation for y. On the right hand side, I see two terms. It's my first term that has the variable of interest. I'm going to add 40 to each side. So I've got x plus 40 is equal to y plus 6 quantity squared. So now I'm going to write the y plus 6 quantity squared on the left hand side, and I'm going to take the square root of it. On the right hand side, I'm going to take the square root of x plus 40. Now for right now, when I know that when I take square roots of a variable, that introduces a plus or minus into my equation. Alright. That plus or minus really means that I have two equations. So we're being lazy. The equations are so close to being identical, people don't like writing it a second time with having this one being plus and this other one being minus. So they just came up with that shorthand notation. On the left hand side, when I take the square root, that exponent of 2 goes away, and I have y plus 6 is equal to this plus or minus square root of x plus 40. Well, now I'm actually going to split this into two equations, and I'll show you why in just a second. When I subtract 6 from both sides, I'll have the y by itself, because remember, I'm trying to get that variable by itself, and I had two terms, so to get rid of the term that didn't have my variable of interest, I subtract. So I move that to the other side, and I'm going to take the minus sign and call that one equation, or I've got when I subtracted 6, and this time instead of subtracting the radical, I'm going to add the radical. Alright, now let's take a closer look. When we switch the domain and range, we wrote down the inequalities, and we want to, again, technically, I guess we should write those with each equation, but I usually wait, and now I come down and write them. I need y to be greater than or equal to negative 6, and x greater than or equal to negative 40. So let's take a look at these two equations. Well, hey, I see a negative 6 in both equations. And this radical, remember that's the principal square root, that's a positive value. So on the left-hand side, I've got negative 6, and I'm taking away from negative 6. I'm making that smaller. And on the right-hand side, I have negative 6, but I'm adding a positive amount. That means it's going to increase. Well, that's what I want, values of y that are greater than or equal to negative 6. Because of this restriction, it allows me to not just have plus or minus, to eliminate when I subtract the equation, and I'm going to keep the addition. So now, when I think about what that graph looks like, the square root of x looks like this. The plus 40 is going to be a shift to the left, 40 units, and the minus 6, if I move it after there, it's a shift 6 units down. Hey, that passes the horizontal line test. Remember, I knew that this inverse was not only going to be a function, but it was going to be a one-to-one function because they are inverses of each other. Alright, so I'm ready. I'm done, really. I'm just going to write my final answer in function notation. And it should be obvious that I don't have to write the x greater than or equal to negative 40, because if it were less than negative 40, that would be a negative number. Value is greater than negative 40, this is going to be positive, and just because the equation I picked, y is always going to be greater than or equal to negative 6, so now it's no longer crucial that I keep running this constraint down, because it's obvious from the equation, from the definition of a principal square root and just the way it's written. So if I have g inverse of x, I can just write it as negative 6 plus x plus 40, and that's my final answer. I know that this is the inverse of the original function they gave me, and it included that domain, and like I say, I knew from the start of the problem that this was going to be a one-to-one function, so they're inverses of each other. Well, I hope that helps.